Welcome to Lecture 4 of Computer Application for BBE. The materials in this lecture cover the textbook Chapter 5 and 6, where routing methods are introduced. We start today's lecture by introducing roots. I think you have learned the term and are familiar with this quadratic formula solution of x for the given equation fx equals 0. The x are called the roots for fx equals 0, and it's quite straightforward formula. You might think that most nonlinear equations could be solved directly just like this example. But in the real world, there are many that cannot be solved in such a straightforward way. In those cases, the alternative is an approximate solution technique. What's different from roots are the optimization results including maximums and minimums, shown as the peaks and valleys in this figure. The intersects of the curve with the axis are the roots, which is the focus for today's lecture. Let's revisit the bungee jumper's problem in a different point of view. The heavier the jumper, the quicker he or she achieves the free fall velocity of 36 meters per second. So there's a weight limit for the jumper to jump safely. So what is this weight limit? Our original velocity equation Vt is shown here, and it cannot directly be used to solve the weight limit problem, because here m is implicit. An alternative way is to move Vt to the right side and so that we can form a function of m, which is fm. Once we plot the function, we can easily target the root for the bungee jumper's problem. The function crosses the m-axis between 140 and 150 kg. Visual inspection of the plot provides a rough estimate of the root of 145 kg. There are different cases for root problems. Usually, roots can be real, complex numbers or repeated. To look at the roots within a range of xl and xu, cases A and C here indicate that if both fxl and fxu have the same sign, either there will be no roots or there will be an even number of roots within this interval. Cases B and D indicate that if the function has different signs at the end points, there will be an odd number of roots in the interval. There are exceptions, of course, shown on the right side of this slide. The upper plot shows multiple roots that occur when the function is tangential to the x-axis. And the bottom plot shows a discontinuous function where endpoints of opposite sign has an even number of roots.